Mm. So in last video we saw about the compute service. In this video we'll see all storage service of AWS. Mm. Right. So beginning with Amazon S3. Okay, this is something like S3 is a cloud object storage. Okay, what is S3? Amazon S3 is an object storage service that offers industry-leading scalability, data availability, security, and performance. Store and protect any amount of data for range of use case such as data lakes, websites, native web application, backups, archive, machine learning, and analytics. Amazon S3 is designed for 11.9 seconds durability and stores data for millions of customers all over the world. Okay. Use cases like build a data lake, run big data analytics, artificial intelligence, machine learning, run cloud native application, build fast, powerful mobile and web-based cloud native apps, backup and restore critical data, and archive data at the lowest. All right. So we'll see some one example, to create an S3 bucket using AWS account for storing and managing data. Usually, okay. So the process of configuring S3 bucket, versioning for version control and file management. We'll see this example. What we do here is first we create an S3 bucket, okay? Then we enable bucket versioning for an S3 bucket. And then we upload files to that bucket and re-upload the same file to the S3 bucket. And we will see, come to know what version it is. Like for example, if you upload the first file, there is version 1, and like if upload the different file to that bucket, the version changes. So if you want to restore the old version also, you can do that, right? Yeah. And now we'll see the concept called configuring intelligent tiering archive, right? Intelligent, this, okay. Amazon S3 intelligent tiering storage classes, okay. So just a brief, Amazon S3 Internet is the only cloud storage class that delivers automatic storage cost saving when data access pattern changes. Okay, without performance impact or potential overhead. The Amazon S3 Intelligent Tiering Storage class is designed to optimize storage cost by automatically moving data to the most cost effective access tier when access pattern changes. For a small monthly object monitoring and automation charge, Whisper Intelligent Time monitor access pattern and automatically moves objects that have not been accessed to lower cost access tiers. All right. Benefits will see automatic saving, first and only lower cost. Okay. So here's a diagram. See, here we put S3 intelligent tiering delivers automatic storage, cost saving in free, low latency, and high throughput access tires when access pattern changes. Okay. Access pattern are monitored to automate object movement between access tires. So here you have different tires, I mean the pattern. Okay. We'll go with one example. Okay. So to set up an S3 intelligent tiring archive configuration to optimize storage costs by automatically transitioning objects to cost-effective access layers based on changing access patterns. Okay. So we'll see like in how we can do this. We create a new intelligent tiring archive configuration as you can see. Then what we do is if they if there is a frequent access tier data access of often, frequent access data. I cost and low latency. We go with frequent access tier when data access often. Okay, for example, if the data is 30 days inactivity, okay, then what we go do is when we go with infrequent access tier, data access rarely, where frequent access tier will go when data access often, where it's very high cost and low latency, all right? Okay. Infrequent access tiering, we go when data access rarely. For example, like if there is a 30 days inactivity of accessing data, it is this is lower cost and higher latency. Okay. Okay. There is one more. We have archive access tier. Okay. If the data, the stored data, if it is inactive for 90 days, what happens? It transits from infrequent access tier to archive access tier automatically. Where the data is rarely accessed. All right. Here it's lowest cost and archival data. Okay. There is one more. We have that deep archive access tier. Very rare access. If there is very rare access of data, then it transits to deep archive access tier where it is very cheapest for long term data. All right. So, yeah. So just to keep in mind, very rare access data, we go with deep archive tier. Data rarely accessed, then we go for archive access tier. For example, 90 days. If there is like if there is like infrequent data, 30 days inactivity, then it will go with the infrequent access tier. Data access rarely. And if the data access is more, always high low latency, then frequent access it will be. All right. Yeah. Okay. Now I wanna discuss about concept called age-based retention. All right. So imagine, okay, you have a folder on your computer where you store temporary files. Over time, so these files are no longer useful and you want to delete them automatically. After 5 days, to save space, this is done using life cycle rules in a S3 bucket. Okay, that is nothing but age-based retention. These rules help AWS automatically clean up or manage your data based on trends. All right, just a moment. That you want to set it back. Yeah, hello guys. So we were discussing about age-based retention, yeah? So just a moment. Mm. So what we're discussing about like, okay, imagine you have a folder, okay, on your computer where you store temporary files, where you, over time, these files are no longer useful, okay, and you want to delete them automatically after 5 days to save space. This is done using lifecycle rules in an S3 bucket. Lifecycle rules in S3 bucket. Lifecycle rules S3. Yeah, yeah. What happens, So this is done using lifecycle rules in an S3 bucket. These rules help AWS automatically clean up or manage your data based on time. Based on time. Okay. We'll see. What for an example? First, what you do, you add the files are added to the S3 bucket. For example, file 1, file 2, file 3. The file 1 is 1 day old, file 2 is 5 day old, file 3 is 10 day old. Okay. What happens here? Then the life cycle rule checks file age. Okay. For example, like file older than 5 days are flagged for deletion. Here, which is that file? File 2, which is 5 day old. So this what rule we have said? Files older than 5 days are flagged for deletion. So then what happens? AWS automatically delete flagged files. Remaining files, what are those? File 1, which is 1 day old. The deleted files are file 2 and file 3, which are 5 day old, and the file 3 are 10 days. These two files are deleted. All right. So this is nothing but life cycle rules of management. Right. Then we will see how to implement object replication between S3 buckets. Okay. Object replication. Replicating objects. Okay. Good. First, we see the procedure here. First, we create two S3 buckets for source and destination. We add a file to the source bucket. We have two buckets, that is source bucket and destination bucket. We add a file to the source bucket. Create a replication rule from the source bucket. Replicate the object file from the source to the destination bucket and delete and verify the uh, object file. Okay. Here, what is happening is S3 object replication is a feature in AWS that allows you to automatically copy object files from one S3 bucket to another S3 bucket in the same or different region in the same region also. Okay, basically object replication is a feature in the AWS that allow you to automatically copy objects from one S3 bucket to another S3 bucket in the same or different region. This feature is useful for disaster recovery, all right, and cross-region backups, maintaining identical data sets across locations. Disaster recovery, cross-region backups, maintaining identical data sets across locations. Okay, we'll see how to do this. For example, we create buckets, source bucket as, for example, in region US East 1, we create the source bucket. And the destination bucket we will create in region US West 2. In East 1 we have US East 1 we have one source bucket, and the destination bucket is in US West 2. Alright. Then what we do, we add a file to the source. For example, some image file .pgf. We upload to the source bucket. Now what we do, we create replication rule. What the rule says, replication rules says replicate all the objects and enable delete marker rule. I'll tell you what is a delete marker rule. Then what happens, it replicates the file from source bucket which contains image.png, which is copied to destination bucket, and also that contains now image.jpg. Alright. And then when it's done, delete from the source bucket whatever that image is deleted, and in the destination bucket image.dpg is retained. All right, so this rule whatever we put, right, accordingly it will act. So the rule what we put, replicate all objects and enable delete marker rule. All right, yeah. So this is about object replication between S3 bucket. So we'll see. Why use replication? Different storage class. You maintain object copies under different ownership. When to use cross-region replication? Meet compliance requirement. When to use workflow requirement? For site encryption list. Okay. Now we see uh, how to demonstrate server-side encryption using S3 and KM. Okay. Okay, we'll see the steps. We protecting data with server-side encryption. Okay. Server-side encryption is the encryption of data at its destination by the application or service that receives it. Amazon S3 encrypts your data at the object level as it writes it in a disk in AWS data center and decrypts it for you when you access it. As long as you authenticate your request and you have access permission, there is no difference in the way you access encrypted or unencrypted objects. For example, if you share your objects by using a pre-signed URL, that URL works the same way for both encrypted and unencrypted objects. Additionally, when you list objects in your bucket, the list API operation returns a list of objects regardless of whether they are encrypted. Okay. server-side encryption using S3 and KEMS we'll see, okay? But we'll see the steps. Create an S3 bucket with SSC, S3 encryption, okay? Server-side encryption, S3 encryption. Create a key management service, that is KMS. Create an S3 bucket with SSC, KMS encryption. Okay. There are two types of server-side encryption in AWS for security, securing data stored in S3 buckets. Okay. First is server-side encryption S3, that is Amazon S3 managed keys. Amazon S3 managed keys. AWS automatically manages encryption keys for you here. Okay, and we have one more KMS, that is server-side encryption key management service. AWS allow you to manage encryption keys using the key management service for additional control and security. Additional control and security, okay? First, what we do, we create S3 bucket with server-side encryption S3. For example, S3 bucket encrypted using S3 managed keys, okay? Where here, file automatically encrypted, where the AWS will handle the keys, okay? In the KMS, we create KMS key by, for example, key as something like CMK demo, and we give permission to customer. Here, we have one key, which key is ready for encryption tasks. Okay. Now, then what we do is, once we create a key, we create S3 bucket with this KMS. What we do is, we create S3 bucket and we link this bucket to that whatever key that is we are created. Now here the file, whatever the file we have upload, right, that file will be encrypted using KMS key. In yes, server-side encryption is S3, Amazon itself will say here whatever the key we have created, right, from that the KMS, the file will be encrypted, right? Okay. Next we will see about creating and mounting EFS on a Linux server. Elastic file system. We'll see about elastic file. We'll see about what is this elastic file system. Okay. This provides serverless, fully elastic file storage so that you can share file data without provisioning or managing storage capacity and performance. All right. So we will see how to create customize and mounting of an Amazon Elastic file system across multiple AWS instances, right? First, what we do is we create and customize an Elastic file system. We create a security group to configure network access. We create AWS instance to access the EFS, and we install EFS on the created instance, right? Just to like tell you, EFS is nothing but a shared file system is created in AWS. With very simple definition, we'll see what is this. Elastic file. Okay. So the feature of this is there is no server management. AWS only will handle it. Automatically grows shrink as the files are added or deleted. Works like a traditional Linux file system, right? Multiple availability and high availability. Data is stored across multiple available for durability and supports thousands of connection and GPUs. Multiple EC2 instances can mount the same EFS. Right? See, use cases are like lift and shift applications, shared file storage for web servers or containers, or for example, like ECS or machine learning pipelines, home directories for user-based instances. We'll see like why we use this, okay? See, imagine a website, you know, hosted on multiple EC2 instances for high availability. All of them need to access the same file, image, configs, logs. EFS allows multiple EC2 ins. This is the main point, guys. You have to go. EFS allows multiple GC2 to read write to the same file system, just like a network drive. That's it. This is a simple. So we go for this EFS. All right. read write to the same file system. So next we'll see about creating and deleting keys with Amazon KMS. To create and delete customer managed keys, using Amazon KMS and control access to your encrypted data. But what we do, we create a customer managed key, delete a customer managed key. First, okay, we go to the KMS, we create a key there. This is something like a locker, you know. Uh, for that locker, we give access like, okay, key is ready. And then, so imagine you have a locker that is a KMS key, okay, to store important files. You can create a new locker, give people access, and later, what you can do is later you can delete the locker when it is no longer needed. Similarly, Amazon KMS also we can use like that to create and delete customer managed keys using Amazon KMS and control access to your encrypted data. You create a customer managed key, that is you go AWS KMS, create a key. For example, imagine that as a locker, give access, key is ready. Okay. And if you want to delete same KMS, go to KMS, select the key, schedule deletion, like select key, schedule deletion, like set 730 days waiting, confirm and delete, and key will be deleted. Okay. Something like you have a locker to store your important file. You can create a new locker, give permission, and later delete the locker when it is no longer required. To delete it, what you do, go to KMS, select the key, whatever you are like, the locker you have, schedule something like for the deletion, set like 7 to 30 days waiting, and then you delete it. Okay, and key will be deleted. Something like that. All right. Or else, we'll see. So in AWS KMS will let you create and manage cryptographic keys to encrypt, decrypt. You can use it with service like S3, EBS, RDS, Lambda, as I told. There are two main types. Customer managed keys. You create and control this. Okay. AWS managed keys. AWS creates and manages these for you automatically. All right. Creating a KMS keys. Okay. So what you can do, you can create key. The Yeah, this is important. These are the steps which I already explained. This is very important. Deleting a KMS key is permanent. After the waiting period, it's gone. Any data encrypted within the deleted key is unrecoverable. Okay. Use key deletion with cautious, especially for production environment. Okay. What do you do? Create a key, choose, symmetric for most common symmetric key usage, encrypt, decrypt, sign, verify. Set an alias, easy name to reference the key, alright? Configure, key administrator. So I am user roles, who can manage the key, alright? And key users, like I am user role, who can use it for encryption, decryption, review and create, alright? Same for deletion as well. Select the key, schedule deletion, okay. After this time, I don't want this key, and yeah, it will be deleted. It's basically creating and deleting the key. It's like, okay, when you create, telling, okay, I created a key, I'm giving authority to these people, and if I don't want that key, I schedule a time and it get deleted. Okay, or just to control access to your encrypted data. That's it. If I don't want the data, I want to delete it. So I'll put a duration and I will delete it. Okay, yeah. Next, we'll see to create a glue data catalog using AWS Glue for seamless organization and efficient cataloging. All right. Yeah. What do you mean by Glue data catalog? AWS Glue data catalog. Let's see. AWS Glue data catalog is a centralized repository that stores metadata about your organization data sets. Okay. It acts as an index to the location, schema, and runtime metrics of your data sources. The metadata is stored in metadata tables where each table represents a single data store. All right. So what do we do? AWS Glue Data Catalog organizes and maintains metadata for your data sets stored in Amazon S3, RDS, DynamoDB, and more. It's mainly for your organization. It stores the metadata about your organization data sets. Okay. It acts as an index to the location, schema, and runtime metrics of your data sources. The metadata is stored in metadata tables where each table represents a single data store. All right. So to do this, what we do, we create a VPC endpoint, we create a AWS Glue data catalog, and we run the crawler and add data source. Okay. For example, tell you a company stores raw data in Amazon S3. Okay. Some raw data. What happens? This glue crawler, it will automatically discovers, catalogs, and organizes this data. Okay. Analyst used Athena, that's a service, to run SQL queries on this data without setting up a database. It's very easy, no? So here the glue will automatically discover, catalog, and organizes this data. So that's the good win. See, Amazon Athena store and query table metadata in the data catalog for the Amazon S3 data using SQL. So this is SageMaker also use this. So mainly is to store your Um, Amazon Glue organizes and maintains metadata for your data sets stored in Amazon S3, RDS, DynamoDB, and more. All right. Okay. So next, we'll see about querying S3 bucket operation with Athena. Amazon Athena is a query service that makes it easy to analyze data in Amazon S3 using standard SQL. Okay. So to execute a query within AWS Athena for performing operation on a designated S3 bucket. So what we do, we create a S3 bucket to store the logs, and we execute queries in Athena. Basically, here we to run SQL like queries on the logs to analyze data usage. Okay. S3 bucket is logging all activities. Athena is set up to analyze the log. So we can track data usage with SQL queries. Use case. So security audits. So find out who accessed sensitive data. And for example, like cost monitoring, see how much data is being transferred. Performance like detect high usage patterns, optimization. So these are all things we can do by Athena. So using standard SQL, this basically in Athena, you will run SQL queries, and also it's a serverless, so there is no infrastructure to set up or manage, and you pay only for the queries you run. To get started, all right. So just let's see this a serverless service that doesn't require any additional infrastructure to scale, manage, or build data sets. It runs directly over Amazon S3 data sets as a read-only service. Let's see here, AWS, Athena. Mainly used to analyze data directly in S3 using standard SQL. No infrastructure to manage, no, all right. It store data in S3, define table using a schema either manually or via Glue data catalog, query with SQL through the Athena console or API. Results are written almost instantly and stored in another S3 bucket. Okay. You have a log file or CSV data in S3. Okay. You want to run SQL queries like, okay, select user ID const start from log, where event type is equal to login, group by user ID. Okay. So you run this in Athena and you will get all the data. Huge data sets in S3 without moving data. It's mainly, to query the data in S3 without any infrastructure. That's the thing. It's an interactive query service that lets you analyze data directly in S3 using standard SQL. Okay. It's a query service. Athena is a query serving data catalog, that's for organizing the data, maintain metadata actually. Yeah. And these are pretty much about the storage services I want to share. So in the next video, we'll discuss about the VPC networking and content delivery, guys. Right? Thank you so much. Bye bye. Take care.